This video will be looking at identifying probabilities from chance experiments. And before we look into this skill that can be found within the chance topic of essential assessment for Year 7s, there's a bit of terminology that you will see within this skill that you probably have not seen before. The first one here is PR, and this just means probability. Okay, mathematicians are efficient, I was about to say lazy, are efficient in their terminology, so we try to find shortcuts. So instead of writing probability every single time, we just use the letters PR, capital P, small r. Then we have these four symbols that you might have seen in primary school. The first one is less than. Okay, this is just a symbol that means less than. So instead of writing the word less than, we can use a symbol. The second one is less than and equal to. So less than and equal to. And the and has that little line underneath here to indicate this. Okay, now this will make sense in a bit of time when we put some context into it. The third one is more than, so it's the opposite of this less than, and it's pointing the other way. And the last one is more than and equal to. Now you can consider these ands as more, less than, and slash or depending on the context of the question, and you'll see what I mean in a second. So this right here might not make sense without some context. Let's put some context into it. We have a 6-sided standard die, numbers 1 to 6, or a fairly, it's a fair die, there's no bias to it. So each number is equally likely to land. So example, to get a 1 is more, not more or less, it's exactly likely to get number 2 or 3 or 4 or 5 or 6. I don't know why that took me a bit to get out. But what's more important is this here. This is saying PR, open bracket, more than or equal to 5, close bracket. What does this mean? This is a question, and this is asking what is the probability of? And when we have a probability of something, it always starts with opening and closing brackets, and inside those brackets is a certain statement. And this statement is saying we want to know the probability of getting a number that's more than or equal to 5. Okay, and we know that it's based on this symbol here, more than or equal to 5. And here's where that or is coming into play, because I can't get a number that's more than and equal to 5. That doesn't make sense. But we can get a number that's more than or equal to 5. So in other words, let's have a think about the numbers on a 6-sided standard die that is more than or equal to 5. So if I were to list these numbers here, there are only 2 numbers in that scenario that can work. 5 and 6, because 6 is higher than 5 and 5 is obviously equal to 5. So there are only 2 of these numbers that work in this scenario. So the probability of this happening is a 2 in 6 chance, because there are 2 numbers that fit this criteria and there are 6 possibilities all up, which then simplifies down to 1/3, as your highest common factor in both of these numbers are 2. So if I divide this by 2 and divide this by 2, that's how we get our 1/3. Alternatively, you can use your calculator to double check this. You can clear this, put your fraction in, 2/6 will automatically simplify to 1/3. Or in other words, let's say you're playing Monopoly and you're only using one of the dice for whatever reason, but you needed a number that was 5 or higher than 5. So a 5 or a 6. There's a 1 in 3 chance of that happening, because in that scenario, that's one of the scenarios there. 1 out of 3 chance, because there's scenario 2 and scenario 3. Or 2 in 6 if we're doing 1, 2, 3, 4, 5, 6. Okay. Now let's have a look at these questions to see what type of questions you'll be exposed to, and you will definitely see this type of question pop up. But now that we got some insight with terminology, you should be hopefully comfortable with this. The first question here is, if a marble was selected without looking, what is the probability of selecting a pink marble? So we know that the answers are given to us in fraction form, so we have to put this answer in fraction form. The first thing we want to do is count how many marbles there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the amount of possibilities there are 12. And how many of them are pink? Are 2. So there is a 2 in 12 chance. My highest common factor in this case is 2. So there is a 1 in 6 chance of a color being pink when selecting from this sample here. The second example, and it's a bit of a long question, so I might have to swipe to the side for this one. If a coin is selected without looking, what is the probability of selecting a $1 coin as a decimal? Type your answer in the space provided, correct to 1 decimal place. And I'll just write that here, 1 decimal place, correct 1 decimal place. Okay, let's have a look at this. We have 5 coins. There are 5 coins, so the amount of possibilities there are 5. And of the scenario, 2 of them are $1, okay? Because that's what it's asking here, $1 coin. However, it's asking for the answer in decimal form. Now, there are 2 different ways. I'm going to show you the just easy, simple way with your calculator. And remember that SD button from standard to decimal? That's what we're going to use. So 2 over 5. Make sure you press the equals to execute it, then press SD. And in this case, in decimal form, our answer is 0.4. So find your fraction and convert this into decimal, okay? The third example, if a coin is selected without looking, what is the probability of selecting a 10-cent coin as a percentage? So first things first, let's get this into a fraction form. Let's see how many coins there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And of those 10, how many are 10 cents? 1, 2. There's only 2. So there's a 2 in 10 chance. But we don't want this as a fraction, we want this as a percentage. So whenever you want to find the percentage of something, you just multiply this by 100. So get it in fraction form, 2 over 10. Make sure you go across and go times 100. So in other words, there is a 20% chance of selecting a 10-cent coin from the selection here. We're now going to look at that example where we can see that terminology pop up. When a standard 6-sided die is rolled, what is PR open bracket less than 4 closed bracket question mark? Now I purposely sounded like a robot there. Okay, what this is saying is what is the probability of obtaining a number that is less than 4? And you'll notice that it's not including that line there, so we don't care about that 4. We just want numbers less than 4 and not including. So if we list the numbers here, 1, 2, 3, 4, 5, and 6, the numbers that are less than 4, 1, 2, and 3. We don't care about 4, 5, or 6, so in this case, there is a 3 and 6 chance. However, I didn't put 3 in 6 as my answer because I know this simplifies to half, because half of them are less than 4, not including 4. So in this case, the answer is 1 and 2. And the last example, you need a bit of context in order to answer this question. Now you can always use Google if you ever get stuck to find out some information. But this question here says, if a card is drawn at random from a full standard deck of playing cards, what is the probability of obtaining a heart? Simplify your answer if possible. Now for those who don't know, a full standard deck of cards, of playing cards, all up, there are 52 cards within a deck. Okay, 52 cards, and this isn't including the 2 jokers. There are 2 jokers on the side, but for now, let's just look at 52 cards. From the 52 cards, there are 4 types. The first type is a club. These are called clubs, okay? They kind of look like a clover type of plant. Not a 4-leaf clover, but specifically a 3-leaf clover in this case. This is clubs. The other one is a spade. Spade. And these two traditionally are black. It's a spade. The other 2 colors are hearts and diamonds. So hearts and diamonds. And these 2 are traditionally red. Okay, so we have these 4 types of cards that we have within a standard deck. And these cards vary from ace to king. And when I say ace, the ace is also considered as the number 1. We just say ace. So we have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, traditionally for 11, queen, traditionally for 12, and king, traditionally for 13. And so from this, here within our clubs, we have ace of clubs, 2 of clubs, 3 of clubs, etc., all the way to king of clubs. And this counts for 13 types of club cards that we can have. And again, this happens for spades, and again for hearts, and again for diamonds. If you were to type in full standard deck of playing cards into Google, and you go into the images, you will see all the different types of cards, all 52 cards. Now, with this in mind, this is asking for what the probability of obtaining a heart card is. Well, we know that from hearts, there are 13 out of 52 cards. And put simply, this simplifies to a quarter. And it has to, because if one of them are hearts, the other 3 belong to different suits. 1 out of the 4 different suits, 1 out of the 4 have to be hearts. And you can double check this. You can simplify this on your calculator. 13 over 52 will equal 1/4. Okay? So in this case, our answer is 1/4. And that's a probability of obtaining a heart. Be wary, guys, that when you put your answers in and it's asking for a fraction form, make sure you simplify. You need to simplify your answers. And this is easy if you have a class-based calculator readily available for you to use. Okay? If you do not have one, you can find this emulator. I can put a link of finding this emulator in the description below. You'll just download this, install it, and then you'll have a cool emulator which mimics pretty much a scientific calculator. Okay, until then, I will see you guys in the next video. Bye bye.